We're going to begin our book, Earthquakes, all about Earth's crust, colliding plates, tsunamis, and more. Written by Seymour Simon. Seymour Simon has been called the Dean of Children's Science Books, so this will be a fun read. The author's note. From a young age, I was interested in animals, space, my surroundings, all the natural sciences. When I was a teenager, I became the president of a nationwide junior astronomy club with 1,000 members. After college, I became a classroom teacher for nearly 25 years, while also writing articles and books for children on science and nature, even before I became a full-time writer. My experience as a teacher gave me the ability to understand how to reach my young readers and get them interested in the world around us. I've written more than 250 books, and I've thought a lot about different ways to encourage interest in the natural world, as well as how to show the joys of nonfiction. When I write, I use comparisons to help explain unfamiliar ideas, complex concepts, and impossibly large numbers. I try to engage your senses and imagination to set the scene to make science fun. For example, in penguins, I emphasize the playful nature of these creatures on the very first page by mentioning how penguins excel at swimming and diving. I use strong verbs to enhance understanding. I make use of descriptive details and ask questions that anticipate what you may be thinking, sometimes right at the start of the book. Many of my books are photo essays, which use extraordinary photographs to amplify and expand the text, creating different and engaging ways of exploring nonfiction. You'll also find a glossary, an index, and website and research recommendations in most of my books, which make them ideal for enhancing your reading and learning experience. As William Blake wrote in his poem, I want my readers to see a world in a grain of sand and a heaven in a wildflower. Hold infinity in the palm of your hand and eternity in an hour. Ooh, these pictures. I know you'll see this in your book. It's crazy. The earth beneath our feet usually feels solid and firm, yet 1,000,000 times each year, an average of once every 30 seconds, somewhere around the world, the ground shakes and sways. We call this an earthquake. Most earthquakes are too small to be noticed by people. Only sensitive scientific instruments record their passage. But hundreds of earthquakes every year are strong enough to change the face of the land. A large earthquake in Kobe, Japan in 1995 toppled this freeway onto its side and cracked the roadway in numerous places. This picture is an example of the enormous destruction an earthquake can cause in a heavily populated area. One morning, on a morning of September 19th, 1985, a major earthquake struck Mexico City. It killed 10,000 people and injured another 20,000. Hundreds of buildings were destroyed, including homes and stores, hotels and hospitals, and schools and businesses. This multi-level parking garage, on the page center right, collapsed like a house of cards, while some of the neighboring buildings suffered only slight damage. And I'm sure you can look at this in your book more closely. That's quite a lot of damage. My goodness. Most earthquakes take place in Earth's crust, a 5 to 30 mile deep layer of rock that covers our planet. Cracks in the rocks called faults run through the crust. In one type of fault, called a strike-slip fault, the rocks on one side of the fault try to move past the rocks on the other side, causing energy to build up. For several years, friction will hold the rocks in place, but finally, like a stretched rubber band, the rocks suddenly snap past each other. The place where this happens is called the focus of an earthquake. From the focus, the energy of the earthquakes spread out speeds outward through the surrounding rocks in all directions. The shocks may last for less than a second for a small earthquake to several minutes for a major one. Weaker shocks, called aftershocks, can follow an earthquake on and off for days or weeks. Sections of the crust have slipped past each other along two strike-slip faults and offset this ridge in Wyoming. The picture's down below. Sometimes one side of a fault will slip up over the other. This is what happened along this highway in the Mojave Desert of California on the right. This kind of upward movement is called a thrust fault. Really examine those pictures. They are amazing.